In your interconnects.ai newsletter, you recently published an article about OpenAI's model spec. So, this document details how they steer their model with RLHF toward their goal model behaviors. And yeah, can you elaborate on, I guess, RLHF a bit in general for our listeners that maybe don't know it? And yeah, what your findings were about this kind of model spec document?
Yeah, so RLHF, this reinforcement learning from human feedback, is the most popular fine tuning technique right now. It's interesting to people deep in the weeds of language models because it's a different loss function. I think all this pre-training is done, and then you hear about instruction fine tuning or supervised fine tuning. That's with the same autoregressive loss function that's kind of at the core of modern NLP. And it wasn't always the core of NLP, which is fun to learn about. But this RLHF process kind of brings in this human factor. So it lets the models kind of have some humanness that is hard to capture in data. And then it also is like a really broad loss function. So there's a lot of different things you could try. Like we're just still barely starting at understanding, like, now that we could do policy gradient updates or different types of updates to these models, like how different can we make them in very useful ways. And that's a tool. So RLHF is a tool for doing this. It seems very likely to stick around. If you had me on a year ago, I would be like, oh, I don't know. We're going to try. But at this point, it's everyone's investing in it. Scale AI did a Series F round on tons of revenue. Like, that's built on RLHF. They've pivoted their company for a second time. And this model spec thing is like a nascent corporate direction thing, which I think a lot more companies will do. OpenAI, again, is at the forefront of this. It seems like it's a combo work from John Schulman, who's like this author of this proximal policy optimization paper and one of the four leading authors of deep RL as a field before language models come in, and then also their product team. And it's essentially trying to say like what we want our language models to do, whether or not we get the technical details right. And then they're going to update this document over time as they kind of like better understand their customers and their company culture. And as a standalone document, it's interesting to people very in the weeds like me. Like, what are the examples they give? What is the commentary they give? Like, they talk about NSFW content and like how it's hard to thread that needle, and like the order of command. So like OpenAI has final say on what the model can do relative to the customer and all these things. And just having it in one place is good because eventually we're going to have multiple model providers do stuff like this. And then if you're shopping around, you could see like, oh, what does Google want their models to do, or Anthropic, OpenAI. And it's even something that we want to try to do at the Allen Institute, just to be like, what are we trying to do? Like, we're pretty behind on terms of what the RLHF practices are. Like, we don't have as big of a budget for human data, but we want to be able to say like, these are our goals and we're going to see if we can achieve them. And then we can document how our goals change over time. And it's just kind of a nice feedback loop to be like, RLHF is a messy process, but these are the sort of things that seem tractable to do with it, whether or not it actually works.
Yeah, yeah. And so while AI2, well, at AI2, which is the abbreviation for the Allen Institute for AI, yeah, so while you may be working at those details around RLHF still, you've published a popular paper called Zephyr, Direct Distillation of Language Model Alignment, about how you leveraged distilled direct preference optimization, so DDPO, for intent alignment in smaller models, which allows this 7 billion parameter Zephyr model to surpass the Llama 2 70 billion one, so 10 times as many parameters. How does this approach differ from traditional methods, and what are the implications for scalability, transparency, accessibility?
Yeah, so this Zephyr paper is mostly about the like direct preference optimization DPO paper, kind of making it mainstream. It's funny, just 2 days ago, yeah, Chris Manning had me for a lecture in his class, and he's like, "Oh my god, thank you guys for making DPO seem real." And it's like because there was this big time lag. The DPO paper came out in about June of 2023, and then the Zephyr model was released in September of 2023 as the first real model to make a breakthrough with this DPO method, which is a long time when there's so many labs invested in training these models and releasing them for like PR and product gain. So it's like there's a huge time lag there, and it really built on just strange exploration in terms of experimental details. Like, we need a really low learning rate. There's the meme in AI that 3E minus 4 is the only learning rate that you need, and it works for everything. But this model and the model later at AI2, which was the Tulu 2 model, which was 70 billion parameters, showing it could scale, like both used like a 5E minus 7 learning rate, which is just so outside the realm of normal for most people doing fine tuning and anything with AI at the time. And then there's also this idea of synthetic data, which is this like direct distillation idea. So there is a data set called ultra feedback from a group that's like OpenBMB, which I think is a research group based in China. And that data set, and still to this day, if you compare to other preference data sets like Stack Exchange or Stanford Human Preferences or like Anthropic's RLHF data set, it's just using the methods that we have on this ultra feedback data, which is a mix of completions from models like GPT-4, GPT 3.5, Llama 2, and then the like chosen and rejected completions for creating quote unquote preferences are labeled by GPT-4. So like this data set is 6 months on from Zephyr and Tulu is still what we're seeing as the best. Like by the time this is aired, we'll release some more models trained with PPO or soon after this airs. And we're still like the best results still come from using this data set. So as this conversation goes on, I'll probably like keep beating my drum, which is like we need to get people making more data sets in the open if we want to keep doing this academically and for open source. But I do that in a lot of channels. But it's obvious if the field will move so much. Like we have these Llama 3 models. I'm sure Mistral will come out with something soon, but we're still using the same one data set. And like it was like the first one of its class too. It's like people don't get the first one perfect, especially when it's a research lab, but it's impressive the longevity of it.
Yeah, in addition to Zephyr, while at AI2, you also released Tulu 2, if I'm pronouncing that correctly. There's like
Yeah.
an umlaut over the first U.
Yeah, it's a hybrid camel. It's what a Tulu is. It took me so long to learn this. There's two types of camels, and the Tulu is what happens if you crossbreed them. I didn't come up with the name, but that's what it's named after.
So like they're the mule equivalent for camels.
I think so.
Well, so regardless of the etymology of the term, Tulu 2 is a suite of models for adapting pre-trained language models to downstream tasks and user preferences. How does Tulu adapt where other instruction tuning models and methods fail?
Yeah, so this is really the bulk of this project was about understanding the most important instruction data out there. And then like we saw Zephyr come out. So we're like, let's apply the Zephyr method on top of it. And like the Zephyr method again worked on these models. So it's kind of like a proof of concept that this ultra feedback data works and at different scales. So it's really the 7 dB scale, which again was like to counter the DPO haters, which is like everyone's like, oh, DPO works at 7B. Like no one's going to really use this if it doesn't scale up. And it was like a month later, we're like, oh, look, we did it. And it was just kind of funny. But there's a lot of instruction data sets out there. And this becomes very messy. I think if you're deep in the weeds of instruction tuning, you also see these people that are like independent affiliations that are trading all these models and uploading them to Hugging Face. And they're like, we have a million examples in our data set from like this list of 15 different places, plus some weird filtering heuristics. And Tulu is like the academic version of that, which is focusing on very specific evaluation metrics, trying to understand like particularly some things in like code and reasoning that are harder to improve with the current models, and doing a rigorous study on like how you can it's kind of a two-stage thing that's wrapped into one result, which is how you can improve these with all the data that we have. And then you have a giant data set, and then how do you prune it down to maintain the maximum performance? And what this looks like in terms of Tulu is grad students running a ton of experiments and just like getting really deep into the weeds. And there isn't a systematic answer. It's like the next thing is to do automated filtering. So like the grad students take away from this project and they're like, we can't do this by hand anymore. And they're like looking into ways of doing automatic filtering based on like embeddings, or they're looking at influence functions, which I don't even know what they technically are. But it's like a measure of similarity between instructions, and trying to use this to kind of automate the process of filtering through the vast amounts of instruction data online.